Hi everyone. I'll talk in English. Yeah, thank you. So my talk is called Parsers. I'm really sorry about this date below. It's like very simple mistake, so I didn't have time to proofread the presentation because people asked me to send it yesterday, so I'm sorry for this date. So nobody's heard it before, so don't feel hurt about that. So you're the first people that seeing these slides after me, of course. So my talk is called Parsers, and I would avoid any additional description. So I'll try to focus on parsers, how they work, why they work, and how we can implement one our own. So why parsers are so important? Why do we all hear about them and at least use them? So because the best way to pass data from one part of application to another or from one application to another is just serialization, right? And that's why parsers just came naturally after we decided to serialize data and parse it somewhere. So one less obvious reason is that people asked me to make this talk more hardcore, so that's why I've chosen this particular topic, because it involves theory a little and those. I will not go that high with those lambda approach, but I'll try to be a little theoretic so that people, to fit the requirement that this talk should be a little hardcore. So the plan is that's just easy part, get into classifications of parsers, explaining parsers theory, and maybe some simple examples and then live examples. So the easiest way to build parser is obviously, well, for like library like this or a string like this is just regular expression, right? It's not super perfect, but at least parses email, first part, second part, like the main, etc. So I can deserialize the string into its components, which is actually probably web server does less, or mail server does that when it delivers my email. So it can go into some complexity, more complex regular expression can be applied to get into more details, how email should look like, etc. So each regular expression can be built to describe particular grammar. So what is grammar? So, and also, if regular expressions are so great, why cannot we parse everything with regular expressions, like JSON? Why don't we parse JSON with regular expression? Well, the answer is that regular expression can only parse regular grammars, which is obvious, right? And so what about non-regular grammars? So in order to define that, well, I can say that the regular expression can only parse things that can be parsed with one iteration. So another way from left to right. So if I can go in email, I can go from left to right, from the left part to the right part without getting any cycles around. This can be parsed with a regular expression. So several obvious examples. There's just phone number, email, maybe IP address. I can parse it with one iteration, and I don't need those nothing in loops, and maybe most of the features of the language is not required at all. So let's go to the theory, and let's see how like people from the math world describe grammars. So the grammar in math is described by generators concept. So each generator represents some transformation of a string to another string. And I'll show you this by real-world example. So let's say that we have like really simple grammar that has only two symbols, A and B, and so our grammar should be describing like a string that at first goes A and A B. So this grammar can be described by regular expression, but also can be described in simple math, where you can see like S sign, R sign, A and B, where S and R like non-deterministic symbols. There's like support symbols, and iterations over grammar rules should follow until we actually get rid of all non-deterministic symbols and leave only A and B. So in order to describe email, well, I'll try to a little simplify this by defining some like regular expression similar syntax, and probably this is the way how they were invented actually. So each line here describes not only one rule, but probably a group of rules to parse emails. So S is just the beginning of the grammar, N is the name that precedes the shift 2 sign or @ sign. So, and then there's the domain marked as D, and there's that is marking as zone. So this particular grammar can only parse like one level domain, like google.com, but not drive.google.com, right? So in this way we can describe grammar of the email. And so let's say that we want to define this simple grammar where we have like same amount of the word A, symbols A, and then same amount of the symbols B. So can we parse this grammar with a regular expression? So the answer is actually no, because this grammar contains a thing called recursive or double-sided generators that generate symbols before and after some sign, some non-deterministic sign. And that's why the regular expression cannot parse it. So we get into regularity criteria. So grammar is considered regular only if it doesn't have like recursive generators or generators with the part before and after non-deterministic symbols. So in order to parse that, for example, this is like lines of code of Ruby in order to like define if this particular string matches AABB pattern with the same amount of letter A and letter B. This is like code I wrote maybe in 30 seconds to just parse it. So you can see that there is a lot of stuff right there, and so you don't need at least more than 10 seconds to understand all the details. So if the grammar is non-regular, you actually always need much more code to parse it, whether you use tools or writing it yourself. So regular expressions have powers and limits, right? And grammars can be irregular and recursive, and so there could be recursive parser. But let's get to more real-world examples. So let's take a look at the engineering calculator implemented by Google by some reason, I don't know. Well, but they support actually such kind of expression in their search bar. I can enter any arithmetics with any type of nesting and brackets and any operator. So I can even do this. So it supports function, etc. Unexpected result, 1. Maybe not everyone knows that it's always 1. So yeah. Well, let's try to solve this problem ourselves. So let's try to build parsers that would parse such kind of expression for us. So parser for non-regular grammar is usually to consist of two parts. First thing is called tokenization, where we define each token of the grammar. We say that, okay, so let's define the most deterministic symbol for the grammar. So in this way, we just define those normalized array where we can iterate over and like not parse each time each symbol from an expression, but work at more high level of abstraction. And so after that, so we need to somehow build thing called abstract syntax tree. So in order to do that, we need to perform like recursive operation. It's always recursive because the grammar is non-regular. So the algorithm can be described like this. So at first, we are finding the lowest priority operation in this expression, which is a star or multiply in the first loop. So and then define what the left operator and right operator, then get rid of unnested brackets, and then repeat the step 1 for the left and right node of the expression. So I'll take a drink so that everyone can take a look. So after the end of this operation, we have like a kind of structure how our operation actually looks. So the best thing we do is we define the brackets as the as a sub-arrays of the Ruby language. So Ruby now knows the structure of the expression we have at the beginning. And so in order to proceed this particular AST, so it's really easy. Now we have like one function that can evaluate it really quickly and even perform more complicated operations. And all of that can easily be extended to support even functions and et cetera, et cetera. So this is like extensive approach where you could go in order to implement super powerful engineering calculator, and you will not get stuck with some level of complexity. So in order to make this faster, well, you can use already well-tested libraries called treetop and RACC. So treetop is more popular, but a bit slower. RACC is a bit hard code and used in Rails router, which I will show you next. So, for example, let's take a look at the Rails router syntax. So, as you can see, you actually can define a nested constructors over here, so allowing you to infinite nesting of the curly brackets inside each other. It makes feeling like, oh, well, this is recursive grammar, and I cannot parse it with a regular expression. I need to approach the parser using some library or write it myself. So this is a huge problem and require a recursive parser. And so in order to do that, there's a tokenizer inside of Rails that represents each particular token in this URL as its particular type. So each token in Rails will have its own type. This is like, well, human-readable names of them at the low level. The only thing you have to remember here is L parent and R parent, which is a representation of the brackets. I don't know why it's not left brackets and right bracket, but this name was chosen. And so, in order to parse that, well, we need to say, using the RACC library, that a group could be, we can define a symbol called group, and a group is the something inside of the brackets, right? And an expression can be an expressions with expression. We can extract one particular expression from another expression with this particular statement. And then the last part, so expression could be a symbol, a littler, a slash, a dot, a group, or star, or any other deterministic symbol. So the only one nesting part, nesting or recursive rule over here is the group rule, right? This is the only one recursive rule in a grammar. And so after that, after defining such a file, you can parse it to Ruby or translate it to Ruby or compile to Ruby in order to simply obtain your parser in Ruby. And this stuff, well, this stuff is all available in Rails core. You can like get to know it if you want to. There's a lot of links over there. So thanks for listening, and I hope that it will be interesting for you to review how Rails parser works and maybe implement your own parsers, or maybe you want to try and re-implement JSON parser, and et cetera, et cetera. And all of that will require you to write recursive parsers, which is actually demonstrated how to do. One more thing, well, coming back from the real world, I want to say a few words about situation in our country. I know that it's complicated, and I think that software developers should work harder and harder here to just help and fix the problems with economics our country have. And I propose everyone to do not lose the chance, because not every people in our country have this opportunity to help people to live better. So thank you for your attention, and I'm waiting for your questions.